Okay, now we're on. Okay, well, thank you for that kind introduction. It's wonderful to be here again. I was very happy to accept the invitation of Karina Jimenez Garcia to come here once again. The last time that I was here, she and her husband Neil were students. I just learned just now that they met on the very first day in which they were here at the university. So if any of you are wondering whether you can find true love in physics here at this university, the answer is yes, if you're lucky. And now, after postdocs in Chicago and in Paris, and having done some of their PhD work in my group at the Joint Quantum Institute, now they're back in Mexico at Cinvestav with their own laboratories and probably looking for good students, right? So think about where you want to go next after here. So. I realized that I'm lacking one thing to give this talk, and that's my laser pointer, which is in my briefcase. So I'm going to get that out. You know how it is. You always forget something. At least I do. And, of course, it's at the very bottom. There we go. And, of course, I have to have my laser pointer because I am a laser physicist, even though the talk that I'm going to be giving you has very little to do with lasers. Okay, so I'm going to be talking about the reform of the International System of Units. You've already heard a little bit. Can we get rid of the light that shines on the screen there? Because I think it washes out the slide a little bit. Well, so there has been a reform of the International System of Units, and NIST has played a big role in that, and I've even played a little role back when I was much, much younger in the latter part of the last century. So, as you've heard, the International System of Units, of course, when it was set up, it was in a time when French was the international diplomatic language. So officially it's the Système International d'Unité. And Système International is why we call it the SI. And thank you very much, that's wonderful. And this is the old symbol, and this is the new symbol, and I'll be explaining why that new symbol is what it is. The reason for this talk is because we have undergone a revolution in the system of units. And that revolution has been the most important revolution since the French Revolution brought us the metric system. Because on the 20th of May, which I'm sure you all know is World Metrology Day, we have experienced this revolution in the International System of Units that began with the French Revolution. So, or the metric system, as we often call it. And this is the set of base units of the International System of Units that has been reformed in a way that now bases the definition of each one of the base units of the SI. The 7 base units are now defined in terms of fundamental constants. Now, what does that mean, and how is it possible to define things using fundamental constants? Well, in order to illustrate that idea, and with apologies to Stephen Hawking, who wrote this wonderful book, A Brief History of Time, I'm going to give you a short history of length. Because length is something that was already defined since 1983 by defining a fundamental constant. But let's look back at the history of length. The early approach to standards of length was to use the human body. This was easy. A cubit was the distance between your elbow and the end of your finger. A fathom was the distance between your fingertips when you spread your arms. A yard was the distance between your nose and the end of your finger. And a foot was a foot. And people needed these kinds of measurements. That's misspelled. These kinds of measurements were important in the very earliest of human societies, mainly, I think, because of commerce. Here is a description of one of the first Spanish how shall I say it, explorers, invaders to Mexico, who says that they had all sorts of units of measure. And why? Because of commerce. This wonderful mural by Diego Rivera illustrates not just the vibrancy of these old marketplaces, but also the fact that we're using units of measure to measure things out. And one of those units of measure, it turns out, quite happily, this one here, which I can't pronounce, is the distance from your navel to the ground. And it turns out to be just about 1 meter. So I think that these ancient folk were anticipating that the meter would become the unit of length with this unit. But all of this was wonderful. It was very convenient to have the units of length be related to the size of your body, but it wasn't very consistent. If you were buying fabric from a fabric merchant who was short, you might not get as much fabric as you were planning on getting compared to buying it from a taller fabric merchant. And this was a problem in Europe where people used these kinds of units, as it was a problem here in the Americas where people also used the unit. But people understood this issue a long time ago, and one solution was not to use just whatever human body was at hand, but to use the body of one particular person. In this case, for example, a king or a pharaoh. So in ancient Egypt, the royal cubit was the length of the pharaoh's forearm, and understanding that the pharaoh might not last forever, they enshrined the length of the pharaoh's forearm into a stone standard that became the standard of length. And this was done in a really remarkably modern way. The people who were out in the field making measurements, for example, to build the pyramids, used wooden standards which they had to bring every month to be compared and calibrated against the stone standard. And if you failed to calibrate your standard every month, the penalty was death. These people were really serious about their metrology. And that seriousness paid off because the pyramids are incredibly accurate. The baselines of the pyramid are the same to a tiny fraction of a percent. They're square to 12 arc seconds. This is amazing, and it's because they were so serious about their metrology. So the idea of being serious about measurement and doing a really good job of measurement goes back a long way. And similar artifacts have existed in many places in the Americas, in Europe, and often they would vary from town to town. So this introduced the same sort of problem. Here in a city in Germany, you see the standard of length of a fathom has been put into the wall in the town square. And you can see it's quite a long fathom, so I think this would be a good place to buy fabric. It's a good bit longer than the fathom on this young woman who's comparing her wingspan to that of the standard fathom. But this was different from the fathom or the yard that was used in surrounding Bavaria. And so while it was very consistent within that town, we had an inconsistency from one town to the next. They hadn't really adopted the wisdom that the ancient Egyptians had figured on. And so, at the time of the French Revolution, it was realized that this was a problem. That every place in France, every place in Europe had its own standard of length. And in the spirit of universality, of liberté, fraternité, égalité, that we should have a universal standard for length. And so, the revolutionary metrologists decided that the new standard length should be a meter, and it should be 1/10 millionth of the distance from the the North Pole to the equator along the meridian, just to make sure that it was completely universal along the meridian going through Paris. So they sent out surveyors to measure the distance from Barcelona to, I forget, someplace on the coast of France, maybe it was Calais, and then extrapolated all the way to the poles and the equator, and decided upon a certain length for the meter, and then, just as had done the ancient Egyptians, just as had done the ancient Aztecs, they enshrined this into a physical standard. I don't think I mentioned that they actually made meter sticks that the Aztecs made meter sticks to enshrine this standard of length. And the idea of this, of course, was to provide a measurement that would be good for all times, for all peoples. They cast this medal to commemorate that idea. And this was the meter stick that they made. It was made of platinum, and it was called the Meter of the Archives, made in 1799 and deposited in the archives of Paris. So this was the way in which this principle of universality was put into practice, was by having, once again, an artifact, and the people would have to come to wherever this artifact was to verify their own standards. Well, that was 1799. 1875. Countries from all over the world gathered and signed a treaty called the Convention de Mètres in 1875. And all of these countries agreed that the metric system would be their standard of measurement, and that they would maintain their units of measure in terms of new standards that would be made, a new meter stick, and as it turns out, also a new kilogram, but we'll talk about that in a moment.